Thank you for joining for today's Climate Live K12 session. This is a video series brought to you by the Columbia Climate School for students, educators, and the public. My name is Laurel Zamashihi. I'm the Assistant Director of K12 and Continuing Education, and I will be facilitating your session today. So for those of you who are unfamiliar with the Columbia Climate School, or who are joining us for the first time, the Columbia Climate School was founded in July 2020, and it's Columbia University's first school in 25 years. It's dedicated to advancing transdisciplinary climate research and education. And as a hub for innovative climate solutions, the Climate School brings together experts from across fields to address the most pressing climate challenges of our time. The Columbia Climate School is committed to shaping future leaders to drive climate solutions forward in every sector by offering educational programs for degree-seeking students, high school students, teachers, professional learners, and the public. By equipping changemakers with the knowledge and skills they need, the Columbia Climate School empowers essential stakeholders in the fight for a just and prosperous society on a healthy planet. So what we're hoping to do with these Climate Live K12 sessions is to introduce you to all the interdisciplinary work that is being done at the school through our scientific experts. These are monthly sessions that run throughout the academic year from November to June, and each month we focus on a certain topic that will be directed toward a particular age range. This year, we actually have a special series called Young Leaders in Action that focuses on actions and successes of young people that are leading the way in climate action and driving change in their community. But for today's session is entitled Threading the Needle, Tackling Microplastic Pollution from Clothing. This session is led by Prunella from New York Sea Grant. We're going to have an informational discussion on microplastic pollution, particularly focusing on the contributions from clothing. We're going to explore cutting-edge technical solutions aimed at mitigating these issues and examine how effective legislation can serve as a multifaceted approach to tackling this complex environmental challenge. And together, we're going to consider actionable strategies to combat microplastic and protect our ecosystems. So I'm going to hand it off to Catherine, but before I do, I just want to note that you will see that our chat is disabled, but we do encourage questions throughout the presentation that we'll answer at the end. So please use the Q&A box to populate with questions. This session is being recorded, and we'll send you a link to the recording at the end. And I will also put in the chat our website so you can look at more future and past events, as well as our YouTube page where all the recordings are archived. All right, so with that, I'm going to hand it over to Catherine to share more about microplastics and plastic pollution and solutions.
Hi, everybody. I'm going to get started sharing my slides. If you feel like you can, I would love to hear where you're from or where you're calling in from. I'm calling in today from Queens, New York. I feel free to write it in the Q&A. I might not be able to look at it until afterwards, but it would be really nice for me to know where you are. Okay, I'm going to share my slides. Okay, and let me go. Okay. If you can't see my title slide, let me know. My name is Catherine Prunella. I am a water quality extension specialist with New York Sea Grant. And today we're going to be talking about microplastic pollution from clothing. So I'm assuming that when you saw the title of this talk, you saw the word microplastics. Maybe you had some ideas in your head because microplastics are a really hot topic right now. So we're going to get into it. We're going to start with what are microplastics? Why do we care? We're going to talk about one particular kind of issue, which is fiber fragments from clothing. We're going to talk about some of the solutions being done by researchers, industry, government, and then some personal solutions that you can adapt. So like I said, hot topic. This here is a Google Trends. So a history of every time the word microplastics was Googled worldwide. If you look at the x-axis, it's time. So since 2004 to today, March 2025, you can see that over the last 5-10 years, microplastics have become such an interesting and hot topic that people are increasingly Googling it. And we're at a peak in 2025. People are Googling microplastic now more than ever. So clearly there's a lot of public interest. Microplastics are defined as plastic particles that are less than 5 millimeters. Now, 5 millimeters might not mean anything to you, so I provided here in the bottom right-hand corner a picture of a pile of rice. So a long grain of rice might be about 5 millimeters long. So microplastics, you could think of them as maybe smaller than a grain of rice. There's a lot of different sources and ways that microplastics are made. There's primary microplastics like nurdles or beads. So these are small plastics that are intentionally made to be small. And then there's the microplastics that are broken apart and shed from larger plastic items, like we have a water bottle, clothing, and basically anything that is plastic has the potential to break down into microplastics. Microplastics have been found all over the world in some of the most remote regions. So to the left, we have here pictures of amphipods from the Mariana Trench. Any oceanography students here will know that the Mariana Trench is the deepest part of Earth's oceans. And within these amphipods, they found this fiber. On top, you can see the fiber plastic particle. And to the right, I have, this is a study that studied Antarctic snow for microplastics. You can see in the bar graph on the bottom that, oh wait, here, I love laser pointers. Let me get a laser pointer in here. Yeah, so you can see that these gray bars are fibers. These blue bars are other types of microplastic fragments. So what's amazing is that they found microplastics in Antarctic snow in the West Antarctic Peninsula. And, oh, I'm sorry, this is the Ross Sea, actually. You can see the dot here. And in the gray bars, you can see that the majority of the microplastics that they found were fibers. We're going to talk a lot about fibers later on. But you don't have to go to the most remote regions of Earth to find microplastics. The scary, kind of alarming thing is how often they are found in human bodies. So we know that microplastics have been found in human lungs, so we think that we breathe them in. They've been found in human stool. We think that we ingest them. Microplastics have been found in human placentas, in breast milk, and there is some correlation between microplastic presence and human health effects, but way more research is needed. So this is a study that studied microplastics in patients that had carotid artery plaque, and they found that out of the 257 patients that completed a follow-up, most of them, over 50%, had evidence of microplastics in their artery plaque, and that the patients with plastics in the plaque had a higher risk of stroke, heart attack, and death. So this is a correlation. They found a correlation between patients with microplastics and plaque and these negative health effects. But they said this flat out in the article, this does not prove causality. 150 patients might seem like a lot, but in terms of human health studies, it's a very small sample size. And there could have been other variables that influenced exposure that we need way more research to establish this toxicity, but studies of correlation are emerging. This is a study that was published in 2025, literally in February, so this is a month old. I can't see you, but maybe I'm wondering if anybody heard of this study. If you heard a news article that said humans have a plastic spoon's worth of microplastics in their brain, it's kind of a clickbaity, headline grabber, but the reality is that they found a lot of microplastics in human brains. So on this figure to the left, you can see that they studied livers, kidneys, and brains in people who passed away in 2016 and 2024, and they found that the brain had the most microplastics. And the reason this article is entitled Bioaccumulation of Microplastics is because they found that on average, brains in 2024 had more than in 2016. And then this figure to the right is getting at this correlation between health effects and microplastics that I suggested earlier. They found that in patients that had passed away and had been diagnosed with dementia before dying, they found the most microplastics in these dementia cases. Again, this study does not prove causality. They say that in the text itself, it is another paper about correlation, but a lot more research is needed to perfect the methods with which you detect and analyze microplastics, and much larger sample sizes that span various geographies and various behavioral and personal histories. So there's the why we should care, because we find it in the environment, we're finding it in the Antarctic snow, in the oceans, we're finding it in ourselves. We're going to focus in today on clothing as a source of microplastic pollution. Now, I'm just going to take a second to talk about words. Words are important. So a lot of the text or a lot of the literature around the subject refers to microplastics from clothing as microfibers. Microfibers already have a definition within the textile industry. If anybody here has ever bought a microfiber cloth or cleaning products, like cleaning cloths that are called microfiber, it's because the textile industry defines microfibers as a very specific small diameter fiber. So it's a little bit confusing when you use the word microfiber, because the scientists that are studying this may be referring to little pieces of clothing that are made out of plastic, but then the textile industry is thinking that this is related to a cloth. So there's some misunderstanding. I might use the word microfiber. I might use the term fiber fragment. Bear with me. If you have any questions, we'll clarify at the end. But the reason that we're thinking about microfibers from clothing is because, according to this study, laundry, here we have the global release of primary microplastics to the world's ocean. Laundry is seen as the biggest, if not one of the biggest sources of microplastics to oceans. Listed here are also tires, right? This is how tires work. When you drive a car, the tires break down, the tread decreases. It's why you need to buy new tires every 60,000 miles. Where does that tread go? Those are microplastics, right, that are entering into often waterways. And then there's several other sources of microplastics listed here, but again, we're going to think a lot about laundry over the next couple of slides. Okay, if you will indulge me, please take out your phone and scan this QR code, or you can go online to slido, slido.com, and then there's this number that you're going to type in. I have a question for you. I'm curious, can you see my Slido, Laurel? Maybe if you could just suggest to me you can.
Yes,
Yes,
we can.
what do you think your shirt is made out of? Take a couple of seconds. No cameras are on, so feel free to look at the clothing tag and type into this prompt, what is your shirt made out of? Just curious. Okay, so we have somebody that has polyester. I wonder if that was 100% polyester. We have somebody who has a blend, I'm assuming, by cotton and polyester. So clothing is increasingly made out of blended materials. So it might have X amount of cotton, X amount of polyester. I think we got maybe this is a word cloud, so the more times a word is submitted, the bigger the text will be. It looks like we got a couple of polyesters. We have a wool. I see one more participant typing. Throw it in. Oh, rayon. Okay. Let's take maybe 5 more seconds. Get your last answers in. Rayon and cotton. Great. So we're all wearing a mixture of clothing. Okay, let's see if I can get back to my slide deck. All right. So this is a very broad differentiation between natural fibers and synthetic fibers. So natural fibers like cotton, hemp, linen, wool, down, silk, these are plant-based or animal hair-based materials. And for most of human history, this is what clothing was made out of. To the right, you can see synthetic materials like polyester, nylon, acrylic. And if you look in the far right, you can see the percent of total textile production. This is a figure that was published in 2021. Over half of all fibers and textiles that are being produced today are synthetic. So the difference being that synthetic fibers don't readily biodegrade the way that natural fibers do. Now, this isn't to say that cotton is good, polyester bad. Most cotton that you get in the store is coated in dyes, various types of finishing, things that make it shiny, things that make it wrinkle-free. So even a cotton fiber has a lot of different potentially toxic chemicals associated with it. But the difference being that cotton, a natural unprocessed fiber, biodegrades more readily than that made of polyester. Now, I'm going to touch really quickly on the full extent of environmental impacts associated with the fashion industry. There are many, many large books written about this topic. I can't get to all of it. So I pulled an article that was actually from the Columbia Climate School, and I just jotted down a couple of bullet points. This is not related to we're going to go back to microplastics in a second, but just kind of touching upon the fact that the fashion industry is responsible for a huge amount of greenhouse gas emissions. There is a lot of water consumed for cotton in particular, but for all types of textiles. And then there's a lot of wastewater that's produced. There's human rights issues with how much folks earn, garment workers across the world. You know, a lot of the manufacturing of textiles doesn't happen in the United States, and so they may earn less than a living wage. And then this is the most important point, in my opinion, is that people are buying way more clothing than they ever have. We buy 60% more clothing than in 2000. That was only, for me, that was a lifetime ago, right? So we buy an incredible amount of clothing and we wear it way less than, say, our grandparents did, right? We buy more clothing than our grandparents and we wear it less and we keep it for half as long. And this is often termed fast fashion. And then a very small percentage of that clothing that we wear is recycled. Most of it is landfilled or incinerated. Going back to fiber fragments. So here I have, this is show and tell time. I have here a pair of my jeans, right? This is mostly cotton. I think it's about 90% cotton and then 10% spandex because the waistband has to be kind of stretchy. You can see that this is one solid thing, but when you look at it under a microscope, it's actually a bunch of yarns that have been threaded together and weaved in this pattern. I have here a polyester fleece. If anybody here lives in cold weather, we love fleece, right? It keeps us warm. It has these, if you look at it under the microscope, it has a really open weave pattern which traps air and actually is part of the reason why it's so warm. It's also part of the reason why so many polyester fibers can come off. And then here is a 100% cotton t-shirt. You can see under the microscope that yes, it's cotton, but it has these dyes. And it's got this, again, this weaving pattern. If anybody knits, they might recognize a knit stitch. So how do fiber fragments end up in our environments? Well, when we wear our clothes, just period, when we wear our clothes, fibers are going to come off. Little fibers are going to come off. And if you're wearing a 100% polyester shirt, those synthetic plastic fibers are going to be, if you check the dust in your house or your apartment, you'll see that indoor dust is largely made up of fibers. And then when we do our laundry, you know, you put in the detergent, you turn up the temperature, it gets swished around, it gets abraded, and through that abrasion, little fibers come off and go into the laundry water. And this is what they actually look like under a microscope. I live in New York City where we use wastewater treatment facilities. So that means the water that comes out of your washing machine goes to a wastewater treatment facility. At a wastewater treatment facility, a lot of those fibers are going to get captured into the solid sludge product. That solid sludge product could be incinerated or it could be added to agriculture. That is a way that microfibers or microplastics, fiber fragments, again, I keep using many words for this. This is a way that those fiber fragments can enter into food, is through the solid sludge product. And then the water that is released through wastewater treatment facilities often contains some microfibers because not everything is going to be captured in the solid sludge. And then when you use the dryer, microfibers are atmospherically deposited. If anybody owns a washer dryer, they might have to clean out the vent. If you just do your laundry, you always have to clean out the lint right? Those are the microfibers. But the thing is that these fibers can break down into really small pieces. We use the term microplastics. Now we're thinking actually nanoplastics. So really, really small pieces of fiber can pass through that washing machine, or I'm sorry, that dryer vent and enter into the air. It's also part of the way that it may be able to move throughout human bodies, though a lot more research is needed to understand how microplastics and microfibers and nanofibers move through our bodies. So let's take a second to talk about solutions. Now that I've scared everybody a little bit, let's talk about some of the things that are being done. So part of the reason I'm presenting today is that I'm partnering with researchers at Columbia University's Lamont Doherty Earth Observatory. We are funded by a NOAA Sea Grant Marine Debris Challenge Award to develop a filtration system for laundry washers and dryers, and then collect those microfibers and recycle them. So this is a schematic of the filtration system. We don't need to understand it. We won't walk through it in its entirety. But the point being that we're creating a system that connects to both the washer and dryer and can store the microfibers that it captures, and then the consumer would have to empty that filter. And this is what it actually looks like. It's really just we have this deconstructed washing machine with a bunch of pipes, and this is research in development. This is technology that is currently being developed. And then to the right, I have this very basic cartoon to describe what I mean by recycling them. So very basic. Plastic is a polymer. These are really strong, long chains that are made up of monomers. Polymers are really chemically stable. It's part of the reason why plastic can be such an amazing material, because it lasts, it's durable. And when these polymers, when we are attempting to depolymerize them is the word, and bring them back into their monomer state using catalysts like metal oxides, which can transfer heat to a plastic surface and then break those chemical bonds. We're working on recovering those monomers and recovering those catalysts so that we can repurpose those fibers into something else. And then there's also bacteria, fungus, insects that have enzymes that break down polymers. I heard this ridiculous story from one of our co-PIs about how him and his students left a bowl filled with silkworms and covered the silkworms in a saran wrap, in a polystyrene wrap. And then they went to go get lunch. And when they came back, the silkworms had eaten their way through the wrapper. And then they made they ended up regurgitating that plastic out. So we're exploring natural and chemical degradation methods to repurpose polymers and essentially recycle the microfibers that are collected on the filter. Now, that was some of what the researchers are doing. The textile industry, the folks that make these clothing, there's also a lot of research and development going on right now to create low shed clothing. So various properties that can make it so that a clothing doesn't shed as much. This has to do with yarn preparation, with the fiber length, with the cohesion, with the temperature that you dye it, different additives like biopolishing. This is a little outside my expertise, so I won't get too into it, but the textile industry could work on making clothing that is a more low shed. And then also clothing that is biodegradable. So as I alluded to before, a cotton fiber will degrade more readily than a polyester fiber if that cotton fiber isn't processed. So working on technology that could create more biodegradable clothing, and there are a lot of smaller startups and bigger corporations that are working on this research in New York City even. And then also water filtration at the textile manufacturing. A lot of the fibers that are released from clothing are released when the textiles are made. And water filtration means just filtering those out at the actual factory. And so government, Government, again, water filtration. So the wastewater treatment facility, government can filter for micro and nanoplastics and fibers at the actual wastewater treatment facilities. And then depending on whether or not our drinking water needs it, there could be water filtration for drinking water as well. Education is something the government can fund and do. I'm doing education right now by talking about it. And policy. I'll give you a couple of examples of policy around this subject, and then we'll get into any questions that you have. So in France, this was passed in 2022. It said that by 2025, all new washing machines that are sold in France must include a filter specifically for fiber fragments or microfibers. And textiles with more than 50% synthetic fibers must be labeled with this special environmental label. Now there's already, it's 2025 and there's been issues with the rollout, but this is the only country right now that has a piece of legislation like this existing. Oregon is proposing a similar bill that says that by 2030, all washing machines sold in Oregon must include a filter of 100 micrometers that can capture microfibers. And a similar bill was attempted to be passed in California in 2023, but it was vetoed. This bill was called California AB 1628. It would have required all new residential and state washing machines to include a filter for microfibers. It was vetoed. I have here a couple of reasons for the opposition. We don't have to go into them. Some of the concerns from industry was that a filter could clog, which would create a flooding issue, that the filter might be made of plastic, and so it would therefore shed microplastics as it filters. There's concerns about increased energy and water use, concerns about how effective the filter is. So there's very legitimate reasons as to why this policy was not passed, and this is still a work in progress. And part of the reason why the Columbia researchers I work with are trying to refine filtration methods to address some of these concerns. So if you're thinking to yourself, is there anything I can do? The first bullet point does not necessarily solve the issue of microfiber pollution. But my belief and the belief of the textile scientists I work with is that we should all be buying less clothing and, when possible, buying used clothing. This is an anti-consumption method that is for various environmental reasons. So buy less, buy used. And then for microfiber pollution in particular, you could wash your clothing less. I know that might sound crazy, but ever since I started working on this project, I've been washing my clothing less and it's been fine, right? You can wash a little bit less. You can wash in cooler waters. Hotter water shed more microfibers. You can use gentler cycles, and you can fill up your washing machine because when there's more clothes and less water, there's less actual abrasion. You could air dry your clothing instead of using a dryer. Air drying is very, it's the norm in some countries, and maybe for our great grandparents it was more common. And then there are laundry filter options that can be bought. So I have here an example of something that's called the Guppy Friend. This is a bag. Keep in mind, I'm not getting paid by any of these companies. You don't have to buy any of this. This is just to say that there are some options available, right? This is a bag that you can put your clothing in and you could throw it in the washing machine, and then the bag collects some of the fibers. This is something called a Cora ball. This is something you put it in the washing machine and then fibers get stuck within this one is cool because they're mimicking coral, and so it can capture some of the fibers. Again, I mean, the efficacy of the Guppy Friend and the Cora ball, it's not 100%. It's not where we want it to be. They don't capture 100% of the fibers, but these are existing resources. There's also, if you own your washing machine, there are built-in and retrofit options that you can purchase. Okay, that's the end. I have here, if you'll indulge me, with one more question before I answer your questions. My question for you, and I won't share this. This is just for my own personal growth. What is just pick one thing. What is the most important thing that you learned from this presentation? One thing. One important thing that you learned that you'll walk away with remembering. I'm going to give you maybe 10 seconds, 20 seconds to answer this question, and then I'm happy to take any of your questions.
Catherine, in trying to scan this QR code, it sends us to the first question. Is there a
Oh,
way to
thank
move
you.
on to question 2?
There is. I just have to press question 2. It is now activated.
Ah,
Okay,
perfect.
I'll give you another 20 seconds. So I can start, Laurel, with I see there's some questions in the Q&A. Do you mind if I kind of kick it off? Oh, because we only have a minute.
No
Um,
problem. Yes, let's answer some of these questions. Sorry, I was answering your question. I got a little
yeah,
distracted.
you guys can answer let's just answer the one question. Is there any way to get microplastics out of the ocean, rivers, and seas? As of right now, I don't know of technology that is actually going into the oceans and the rivers and the seas that are filtering, but I can tell you I am 100% certain that they are being developed because I have talked to those researchers. So there are researchers across this country and probably across the world that are currently developing things like robots that can go in the water and do filtration while they're in the water. There's one that's funded out of Cornell University, which is the university I work at. So not right now, but trust that technology and development is catching up.
And if any of you are interested in science or technology or engineering out there are plenty of opportunities for these solutions to come to the forefront. So we're also inviting you in to think about some of these solutions as well.
Yeah, absolutely. Everybody who wrote proposals and got funded to work on these solutions, they started off probably where you were, being like, huh, this is interesting. This is weird. This is a little scary. What can we do about this?
Catherine, my question was also the one listed here that was asking about the silkworms. So if they're eating the plastic, are they then creating like a thread that is plastic?
Yeah, so are they called cocoons when it's a silkworm, or it's a
Oh,
cocoon, right? Yeah, I
I think
think so
so.
so that's what Joe Kim told me, is that they form actual cocoons out of the plastic. So right, it doesn't disappear. It is repurposed. It's in their waste. Does that make sense?
Yes. Could we then, once they emerge from their cocoons, recycle any of that plastic? Like what, or would that go
Yeah.
back into the environment?
No, that's the idea, is can you, because silkworms is how you get silk, right? Like
Hmm.
it's not unprecedented that biology can create a fiber that you make into a clothing. So the idea is, can we take like this cocoon and turn that into a fiber that could then be used to make a polyester shirt, if that makes sense. Yeah.
Yeah, it does. And it's so creative. I mean, these are the type of innovations we need for sure.
Yeah,
Um,
and this wasn't discovered in Columbia's lab. This is known, but we're working on kind of building on that. Yeah.
Oh, love it. And so when we're thinking about, this is a question that I had, when we're thinking about these filtrations that can be put into your washers and your dryers, what would be, in a perfect world, a standard protocol for us as users to like do with this sludge or the waste after?
Yeah, that is a great question. And that is kind of the question. So I don't know if you have a filter in your fridge. Some people like buy a Brita filter and they change the filter. So that's part of the limit. That's part of the issues right now with developing this, is that it would be based on consumers. And then you would really need to educate your consumer. They would really need to know what to do, how often to change it. The filters that exist right now have a model where you then take those textiles or those fibers that got filtered, and you mail them back to the company, because that's how the company then recycles it. But this is a huge topic, because what if you take the filter out and you're like, oh, I'm gonna hose that down. That's a norm. Like I'm gonna rinse it in the sink. Then you're reintroducing the fibers into the water. And so for it to really make sense, it has, it has to be collected and potentially landfilled, or, a recycling method. So it's not a trivial It's not a trivial part of this. It's a huge part of this problem is figuring out how consumers could clean the filter.
Yeah. Oh, yeah. If they were to wash it off, it would be all for naught, right? It would just be going in the
Exactly.
waterways the same way.
Yes.
So we have a question. Is there a way to remove microplastics from the brain or body?
Oh, I don't know. I've been asked this question before. I think the answer right now is I don't know slash no, that doesn't exist yet.
Yeah,
Working on it, probably. I don't know anybody who's working on that problem, but that is going to be a future research area. Like I
absolutely.
said, this is all really new research. That brain paper got published last month. The artery paper that I mentioned got published last year. So it's all very, very new research, emerging research, as we say.
Yeah. And as you mentioned before, more data needs to be, collected to support some of these initial findings. One more question for you, Catherine, if that's okay, unless folks have other questions. So my understanding is that there's actually a lot of microplastics in the laundry soap that we use because it was
Mm.
intended to create more of like a friction wash to deep clean, but then that also means just like more plastics. Are there any soaps that you would recommend using that don't have plastics at all? I mean, they also make it very hard to find because they don't need to list it on the bottle.
I was going to say, I don't have an answer to that question because I don't have a definitive list of what laundry detergents do have microplastics added and what don't. I know that our peers at Columbia have discovered those microplastics in laundry detergent. I don't know though if that's been published with kind of brand names. What I can say is that some research suggests that liquid detergent actually it produces less microfiber breakage than powder detergent. The powder creates more abrasion and that would create more microfiber shedding. But in terms of your question, which detergents don't have microplastics added, I don't feel comfortable giving an answer because I just haven't seen enough data.
Yeah, of course. It's my family's been on the hunt for years and it's like it it could be done, but it takes a lot of digging and like going through all the deep websites because they don't have to list it on their bottle, which makes it very frustrating.
Yeah, I can say that not to name names, but the detergents that come in little plastic wrappers that then
Mm.
disintegrate in the water, they don't disappear. They're just turning into microplastics, right?
Oh, no.
Yeah.
Oh, that's good to know though, so we can avoid those. Thank you so much. It doesn't look like we have any questions, but this was just such an incredible session. I really appreciate some of this cutting edge research that you shared with us because we really are at the forefront of better understanding what all this microplastic means to our human health as well as the solution. So I know there's a lot of room in this space for new technology to emerge. And so I also call on everyone on this call to be a part of the solution and think through those ideas.
Thank you for the opportunity to present and thank you for listening, everybody. I really appreciate it.
Thanks, everyone. I hope you join us next month, and the recording will be on our YouTube, so feel free to check it out. And thanks again, Catherine.
Bye.